What's going on, everyone? Just doing a quick sound check. Let me know if you can hear everything okay. Nice. So welcome to the stream. We are back after about 5 weeks. Had to take one additional week off. I typically do streams, once a month, but some stuff came up, so had to delay it by about a week. And as you are probably aware, this is the databases stream, part of season 3, which is the streams that are in the format of basically questions are submitted ahead of time, about a week ahead of time, if it's your first time joining. And then I go through every single one of those questions and I answer them. I also take some questions from the chat as well. And then we talk about that for about 1 hour. And lots of information gets put out. It's really good. So as far as any channel updates and announcements, I actually don't have any at all. Everything's fine. There's nothing really to add other than I am still working on EMKC contests. I know a lot of people have heard that over and over again, but I really am working on it. It's less about the effort and more about exactly how I want to go about it, whether it's code golf or something else. So still trying to figure out some stuff there. If you have any questions as I go throughout the stream, feel free to put them in the chat and use the Q colon question or question colon in front of the question, and then that will push it into Discord. That way, make sure I see it. I try to watch chat as well as I'm talking, but sometimes I get wrapped up in the content and I just don't see the chat. So best way to ask questions is to use one of those prefixes. And other than that, I think it's time to just get right into it. So for the database questions, there was about 28, maybe 30 submitted, and I think I combined them down into about 24 or so, because of course some people ask the same question as somebody else. I'm probably going to start publishing the questions ahead of time. That way people can see what's being asked. That way they don't ask anything duplicate, but I'm not sure exactly. Hello, Johan. Thanks for coming to the stream. So the first question we got, and I answered them in order. So if you submitted your question first, then it gets answered first. So the first one was asked by Jitendra, which is, can you provide a brief overview about database sizing and process of performing database sizing? So I'm assuming what the question is asking is, how do you prepare your infrastructure for a database? So, and this is sort of a separate issue from the database itself, because typically when one thinks about working with the database, they're talking about doing queries, building tables, and modeling data, but people often don't consider that you also have to prepare for the growth of your data, and you got to prepare for possibly having your application become really popular, which would lead to additional data in your database. So you got to take into account how much do you need to store. So mostly database sizing just involves estimating the growth of your database over time. And a lot of times this can be done by looking at the schema of the database and then saying, okay, well, I have these tables over here, and I have these tables over here, and then the row length, I know it because I already built the table. I know that one row is roughly, say, 300 bytes on average, and then you could say, all right, well, if the growth of this table follows a certain trajectory, then I'm going to be adding, say, 100 megabytes of data to that table, every month or every quarter. And then from there, you can estimate kind of what you need. And then obviously you tack on some additional, kind of headroom, just in case you experience some additional growth. So the hard part about sizing, of course, is you never actually know how fast something's going to grow. Even if you lock in what your database schema is, you say, okay, these are my tables, these are my rows, it's all good. I know how long each one is. It's just, you don't know. You could put out the next $1 million idea, and then you get 1,000 times as much traffic, adding 1,000 times as many rows, and then now you're, kind of a problem. So always go on the high end and always have a plan, for when that database fills up. Take a question from the chat. Oh, Avi asks, what do you think about Firebase Cloud Firestore? So we're actually going to be talking a little bit about Firebase here in a little bit. Actually, it's the very next question, so I'm going to answer that as part of this next question. So this question was asked by Man Who's Billy 1. He asks, why should someone choose a bare bones database when there's Firebase available? And how hard is it to create algorithms such as authentication and real-time updates similar to Firebase in your own database, MySQL, etc.? And is it worth it? So it's tough to compare those two things because they're fundamentally different in the way it works. Like Firebase can be thought of as an underlying data store. In the case of Firebase, it's a JSON document store. Like the Firebase data store is probably closer to Mongo than it is to something like MySQL or Postgres or MS SQL Server. So the Firebase is kind of a data store combined with an application layer that allows people to integrate against it. And specifically what Firebase provides is this idea of real-time synchronization of data across everything. So it's like you would update some model, and then that model would update the underlying data in Firebase, and then Firebase would push down all of those updates to anything connected. So obviously the second part of the question is, can you replicate that using MySQL? And you can't replicate it using MySQL directly because a lot of what's controlling all these real-time updates is not the data store itself, but the application that wraps that data store. So if you wanted to replicate that sort of thing with MySQL, you'd have to write the application stuff around MySQL to make it work. And you absolutely can. You can make real-time excuse me. You can make real-time infrastructure around MySQL, definitely using Node.js or Python or really anything. The thing is it worth it? Probably not, because the reason Firebase is so popular is because they put tons and tons and tons of effort into making it. And if somebody could just rebuild Firebase, in a couple days, then it would make that product a lot less valuable. So, and why would you use one or the other is, a lot of people don't have the need for the kind of real-time synchronization that Firebase offers. A lot of people, they just want just your typical relational database to store their data and run their queries. So in that case, there's simply no need for something like Firebase, and one probably would not use Firebase in a case where real-time stuff is not needed. As far as my preference on Firebase, I think it's excellent technology. It's terrific. I've used it in experimentation. I haven't personally used Firebase in any kind of production software, but I've tried it out, and I think it's really excellent. It's an excellent concept. It removes the need to build that application layer around a database that's not designed for that sort of stuff. Another question from the chat: do you prefer MongoDB or MySQL? So here again, that's I like them both evenly because they have different use cases. Like you can use MySQL for everything that Mongo can do, and you can use MongoDB for everything that MySQL can do. But when people think about like big data, schema lists, and the ability to store and shard your data across thousands or tens of thousands of servers, then MongoDB comes to mind before MySQL does. So it's actually not uncommon to use MySQL and Mongo together. It doesn't need to be like one or the other. So as far as the preference goes, I think if I was choosing a general database, I'd probably choose MySQL just because that's what I've always used. I like the rigid table design. I like the ACID guarantees. And that's what's useful to me for the majority of the projects I do. But if I found a project that had a good use case for MongoDB, then I'd have absolutely no problem taking on that database as well. And that's true of other databases, that are similar to Mongo but different from MySQL. So yeah, same thing. MariaDB or MySQL, they're actually pretty much the same thing. MariaDB is a fork of MySQL. MariaDB, I think, started out as a project to relieve some of the pressure of Oracle that they put on MySQL. But for the most part, the core of MariaDB is just MySQL. In fact, they advertise as a drop-in replacement for MySQL, meaning that all the interfaces are the same, and that's that. So as far as which one I choose, for the extent that I use MySQL, everything I do in MySQL will also work in MariaDB, and the reverse is true as well. So it doesn't really matter to me. This question was asked by Chase. Yes, dogs can learn programming too. Don't judge. So thanks for this question. What exactly is the difference between different DB options such as SQLite, Postgres, etc.? When I was learning Django, it was recommended to switch to Postgres when deploying instead of SQLite. So this is a good question because a lot of times, when I think of major relational database platforms, I'm thinking of MySQL, I'm thinking of Postgres, and I'm thinking of SQL Server. When I think of a relational database that is smaller, I think of SQLite. So, all of them do the same thing, and that thing lets you create tables, it lets you add rows to those tables, it lets you update those tables later, and it lets you query into that data. That's true across all four of those platforms. It's mostly in what is the use case. So for SQLite's good for like prototyping and development, as well as smaller projects that don't involve like a ton of load, database stored across servers, and so on. SQLite's also really good for if you need to embed it into mobile devices. In fact, it's one of the only ones that I know of that is extraordinarily popular, that works well in mobile devices. Like if you need a SQL database inside like an Android and iOS app, the answer is almost always to use SQLite, because SQLite is stored as just a single file, which you could just put inside an app, and then client libraries are written to work with that single file database. So it's ideal. Like with SQLite, there's no SQLite daemon, for instance, whereas MySQL there is, and SQL Server and Postgres, there's actually a daemon waiting for connections to service those requests. SQLite works a little differently. So why they recommend to switch to Postgres, that's probably just a preference thing. To recommend Postgres to somebody without knowing exactly what they need in their database, and to recommend Postgres for that is probably just a preference thing. It'd be like me saying you should use MySQL just because I like it, even though I have no idea what you even want to use it for. And it's probably just because the people that built Django, that's probably what they liked at the time, and so that's what they used. And unfortunately, that's just how a lot of things go. Whoever gets there first, whatever their particular preferences are, end up influencing particular projects. And I think this is no different here. As far as the switch from SQLite to anything else, that recommendation probably came from the fact that databases that are not SQLite are just better set up for scale. And it's just a simpler option unless you're on a mobile platform. So that's my guess. But here again, they can all do the same thing. In fact, SQLite even advertises as having customers that run huge sites that get hundreds of thousands of hits a day on a SQLite database. So, they advertise that it works. I'm sure it does. Next question, this is another MongoDB question. Can we do anything and everything with MongoDB? Yeah, this was asked by Unknown. So the short answer is pretty much. You can do anything you want. The long answer is, MongoDB compared to other databases, it goes about things a little bit differently. So the key difference between databases that are like MySQL and databases that are like MongoDB is mostly in how the data is structured. So with databases like MySQL and Postgres and SQL Server, you define rigid table structure up front. You say, okay, I have table A, B, and C, and then in table A, B, and C, I have columns A, B, C, D, E, and F. And then once you establish that, that's all you can put for that data. You can't put anything additional outside of those columns. If you wanted to add additional data in a table, you would need to actually add another column to store that data. So with MongoDB does not function like that. So MongoDB functions by way of documents, and inside documents, you could store other documents. And documents is nothing more than like a JSON object of, strings, integers, or additional documents, arrays, and various data like that. The other thing is MongoDB does not enforce any kind of schema. Like, you don't have to define the document doesn't have. And in some use cases, this is extraordinarily powerful. So, but at the end of the day, they could both do the same thing. You're going to be equally successful using Mongo as you are using MySQL. You're just going to have to go about it a little bit differently. That's all. Let me check chat here. Let's see. Evgenia S. asked how to make a judgment about DB performance, how to know what to expect from Mongo versus MySQL, for example. So the only thing you could really do, two things. You can look at general benchmarks for how the two perform, but you really got to know, to know how your database is going to perform, you have to first know like what your database is going to have for a workload. So if you know that you're going to get tons and tons and tons of writes, but not many reads, then you'll be able to pick a good database for that. Whereas if you have, a database that's going to have probably 99 reads for every one write, then there's going to be other databases that are good for that. So, but at the end of the day, you got to put some sample data in your database, write queries, and kind of get an idea for how they're going to perform according to those queries. And then once you know that, then you'll kind of know roughly what your throughput's going to be if you got your ratios of reads and writes, correct. And reads and writes is one of the most important things for, understanding the performance of a database, because some databases are good for writes, like Postgres. Some databases are good for reads, like MySQL. And of course, there's some databases that are good for huge amounts of data. Think like Elasticsearch, MongoDB, Solr, and those sorts of things. So you got to understand what kind of workload you intend to put your database under, before you can kind of figure out what is the best way. Anthony, just wanted to stop and say thank you. Keep up the good work, educating people what you're passionate about. Thanks, Anthony. I haven't seen you on the stream before, so welcome to the stream. I hope you find it very useful. All right, next question from the submitted questions. So I think this covers a couple of the chat questions as well. Regurum asked, relational or non-relational DBs. We kind of talked about that. When we think about relational DBs, we're thinking about like strict table structure, like I just talked about before. And when we think about non-relational DBs, we're thinking about document stores. We're thinking about data that is not necessarily like rigidly connected to one another. So when you design tables in a database like, and just as I go about the stream, if I say MySQL, I'm also referring mostly to Postgres and MS SQL Server as well, because they all go about things the same way. The only real difference between the three is some additional features and some performance tuning, but for the most part, they structure data the same way, and the queries are the same, more or less. So when I say one, I'm referring to all three. So as far as relational databases go, when you have a rigid table structure, then you have the ability to say, okay, well, this particular table is related to this table over here by way of what we call a foreign key. And that is one table's primary key inside another table's column set as another key. And what that allows you to do is basically join those two together when you make a query. MongoDB does not work really in that way. You're not really relating data in that way. In fact, if you want to store nested data in Mongo, you simply store it as nested documents, because MongoDB documents can also store documents inside themselves. So that's sort of a different way in how that works. So, but the question was, MySQL and Postgres are both relational databases. Does one handle certain types of workloads better than the other? How does their performance compare? This is submitted by AdiDW. And there's also a related question from Yoast on this. And for the most part, they're the same. Postgres is kind of thought of as the higher tech solution, the one for, like enterprise grade sort of thing. And Postgres is also really good for things like high writes, geo facilities, and then high scalability. And that's not to say that, MySQL is a slouch in that area. MySQL is certainly capable of doing all that as well. But once you reach a certain point, MySQL is going to start choking a little bit on what it's doing. And that's what makes Postgres a really good option. So, here again, you just got to look at what exactly you are intending your database to do. And then from there, you should be able to pick a good option. JNet Reloaded asked, I want to back up my MySQL DB to another Linux Mint. What's the best way to do this other than MySQL Workbench? So all MySQL Workbench is going to do is execute, just look up the MySQL dump command, and that's what you can use to make a copy of your database in a single file. And that's all MySQL Workbench is going to do as well, is it's just going to use the MySQL dump command to get a copy of the schema and then a copy of all the data. And then from there, that's going to just put it all in one file. And then from there, you can restore the database from that file. So the simple answer to that question is use MySQL dump command. It's pretty easy to use. For security purposes, which is better, MySQL or MongoDB? It doesn't really matter. As far as how things are secured, that's really up to the developer. I would say if you're asking, if we're speaking from a standpoint of like SQL injection, then of course, MongoDB is not a SQL database, therefore it's not really susceptible to the typical SQL injection that MySQL would be susceptible to. So I guess in that regard, maybe that makes MongoDB a little more secure. But here again, if you use proper client libraries that have SQL injection prevention, then they're equally secure. As far as the platform itself being secure, I would call it essentially the same. All right, this question was asked by Nangs. When deploying a small-scale web app with a local server, the server and the app go on the same machine in VPS, what steps need to be taken to secure the database, specifically for MongoDB, but can talk about SQL databases? Some kind of insanity. I already learned a few things I didn't know. Thanks. Thanks a lot for the 20. I appreciate that. And I see you all the time in the streams, so thanks for coming out and supporting the stream. It means a lot to me. It means a lot to everybody. Oh, yeah, Nangs is here. Yep, getting your question answered. So there's two things. When I think about securing a server where excuse me. When I think about securing a server where both the application and the database are on the same server, two things come to mind. The first is you got to protect the machine itself. That's the most important thing, because if somebody accesses the machine, especially as the root user, then that's kind of it for your system anyways. If somebody gets root access to your machine, then that's the end of that. But I'd also be making sure that no ports are exposed publicly. So of course, most database platforms, they expose a certain port, and that's what client applications will connect to actually make the request for that database. So I'd be making sure that those ports are not accessible to the public. And when I say public, I mean, like I should not be able to connect to that port on your server. That should be locked down to where only the application can connect. The second thing I think about is to make sure the database is only accessible via the Mongo daemon, and that files aren't accessible by the application. So, a lot of people think, oh, if I use a password in MySQL or a password in Mongo, then it's all unprotected. But the reality is, the underlying data from Mongo and MySQL and other platforms are just stored right there on the system. However, they are typically either a root user or an unprivileged normal user. That way, only the data is accessible to that user, and therefore you can't access it, but that's not always the case. So I would verify that that is the case. Otherwise, because if your application can see the data, then so can anybody else logged in as that user. And if I can see the data and I can take the data, then I don't need your password. I could just take that data. So that's two things I look at: ports and making sure that the stuff is accessible only to the Mongo daemon. Lucas, hey, what's up? Big fan. Nice. Welcome to the stream. So that's why unknown Mongo. It's actually interesting. There's a lot of MongoDB questions. It's good to see that that database is really popular. Like Mongo's been around for a while, and I was a little skeptical of it when it first came out. But and when I say that, I'm referring to about 9 years ago or so. And now that it's matured a lot, I think it's a great product. After I connect to MongoDB and do my CRUD action, and when he says CRUD, he's referring to like create, read, update, and delete. So your standard, database operations. Do I need to close out my connection? Is there anything else that needs to be done at a high level? And the short answer is no, not really. Typically, client software that accesses a database for you on behalf of your application will keep a persistent connection open to that database. And the reason it does that is because you don't want your application to incur the cost of accessing the database, or I'm sorry, opening a new connection to the database every time it wants to access data. So it's commonplace to just open one connection that stays open for the life of the application. That way, whenever it wants to make requests, it just makes requests of that database, and then that's the end of that. As far as closing it out, in fact, if it gives you the option to close it, you probably don't want to close it, because that implies that when you need to request more data, you got to reopen that connection, and that's just additional lag. And database is all about getting the information quick, getting the queries done fast, and not spending any additional time that's not completely necessary for retrieving the data. Yeah, Chase is, I think he sees something outside. He wants to go outside. He'll be okay. He'll survive. We're about halfway done. Let me look at some questions from the chat. Is there a preferred database engine used with Python applications? No. I would say that the database engine that you should pick should be based on your use case, and just simply using Python in itself is not a specific use case to pick a specific database platform. All database platforms will have client libraries written for all popular languages, so you don't really have to worry about there not being support. And that's to say that Python will have a client library for all the platforms, PHP will have client libraries for all the platforms, JavaScript will have client libraries for all the platforms, so you don't have to worry about compatibility there. So there's no specific one. All right, answered that. Let's see. I'm sure that is. Oh, that's a good question. So Roma asks, what is the proper way to sync to MySQL databases on the local and remote server? So this is often, when I read the word sync, I'm assuming what you're referring to is the actual schema. So typically what I do is I use a migrations manager. And the purpose of a migrations manager, and if Calyx is listening, this is actually relevant to you too. This is what we talked about the other day. So the purpose of a migrations manager is to boil down changes to databases into a single file, which have the queries that change the database and then the queries to unchange the database. And those are typically called an up and a down. So like if you have your initial schema and then you want to add a column, what you do is you make a migration. In that migration, you add your alter statement to add the column in the up, and then you add your drop statement in the down, and then you commit that file into your Git repository. Once that file goes to production or other developer servers or whatever, then people will take an action called run migrations. Now what that does is it takes all the migration files that have not yet been applied to their database and it applies them to their database. So in this way, this completely removes the need to do things like, oh hey, I add a field in the table, or oh hey, I deleted some data, or oh hey, I add this new table. You don't need to actually worry about any synchronization issues. You simply just commit your changes to the database along with the changes to reverse those changes, and then you use a tool that applies those to your database. So that's something I started doing about 7 years ago, and it's completely removed so much of the headache. So definitely have a look at Migrations Manager. And as a Shameless plug, I've written one for MySQL and Postgres. It's called RMIG. It's on GitHub, and you can check it out here. Okay, moving on. This is a good question. I understand that for most small beginner projects, it really doesn't matter what database to use. At what scale should we really care about making this choice? So the first point here is that certainly scale is a factor, but it's not the only factor. Like the features and performance of specific areas, can also drive that decision. I know that when I start thinking about scale, it's because obviously first I move a database to its own server. That's the first step. Second step is I give it additional cores, additional space, additional RAM. But once it starts to struggle with, coping with all the additional load, that's being put on it, say like 40 to 50%, sustained, CPU, then I'm thinking, all right, well, I gotta come up with a plan here. So I would say that you should start caring about it once you start seeing significant load, or you start getting the impression that you're going to have significant load in the future. That's probably when I would start caring about that. But you kind of need to make the choice up front. You can't just start with MySQL and then later say, oh, I want to go with Mongo, or start with Mongo and then later say, I want to go with MySQL. And that's because the more data you have in a database, the harder it is to migrate to a different tool. So like if you have 50 million records in MySQL, that is not the time to then decide that you want to migrate to a different platform, because you have to export all that data, and that takes time. It's a lot of data, and then you got to import it into the new database. And in this time, you either have to take your application down entirely, or you have to find a way to reconcile all the differences that occurred during the migration, which for a sizable database could take hours, perhaps. So you want to be thinking about it early, but it's only really a problem once you're experiencing significant load on your database. How important is our knowledge about algorithms and data structures when dealing with databases? Should I put the time to learn about them first before properly learning how to use database or ORM, e.g. Mongo, MongoSQL, etc.? This is asked by unknown. So as it pertains to the database platform itself, it's not really that important, because you as the developer are not the ones responsible for actually structuring the database in MySQL. Of course, that's handled by the platform. Relational databases just have their typical rows and column structure, and that's sort of that. However, when you query data from a database and you get that data in your application, sometimes it's a lot of data, and sometimes it's difficult to work with and very inefficient to work with, especially if you're pulling in, tons and tons of stuff. It's like, that's funny. It's like that basis EM Live from Engineer Man, where questions answered greater than 20, order by smash, thumbs up. Indeed, I like that query. That's good. If that worked, I'd run it. So, data structures and algorithms are very useful when you need to manipulate a bunch of data in an efficient manner. So that's really where the knowledge comes from. So it's less about having the knowledge to use the platform, and it's more about having the knowledge to manipulate the resulting data, because database platforms are happy to give you back as much data as you could store in memory. If you request 10 gigabytes of data from your database, it is more than happy to send that on over to you. And then once it's in your application, you got to figure out how to use it. And I think that's where your DS&A skills are very useful. This is another really good question. This is asked by unknown. I wish the person would have told me who, because this is a fantastic question. I've always struggled to get around the concept of storing images in a database. So a lot of people aren't even aware that you can do this. and we're going to talk a little bit about it. So since we mostly use them to store plain text data and their string representation is quite large, can we use databases like MariaDB or Mongo to store images? Is it better to store them in the regular file system of the server? Thanks. So the answer to can you store images in a database is a 100% absolute yes. You absolutely can. In fact, MySQL has a data type that's specific for this purpose, and it's called a blob, which is a binary large object. And there's some use cases where it makes sense to actually store your images in a database, but there's also use cases where it doesn't. The problem with putting an image in your MySQL database is that the only way to get that image back out is to query it out. And if you have, say, hundreds of thousands of images and people are requesting them a lot, then you really want those to be on a file system. You want those available directly through a web server or a CDN. And for those sorts of things, you simply wouldn't have those in a database like MySQL. However, as I was thinking about an answer to this question, I realized that I just recently actually stored an image in MySQL. So I wanted to describe that use case. So part of an application I worked on required people to sign a signature pad with a virtual pen. And because that image was just a PNG with the black text as the content, the size of this image of the signature was often very small, perhaps like less than 1K, probably more like 400 bytes. And I didn't want to make a whole new image just for this. So it made perfect sense just to put that right in the database and then query it just along with everything else. Convert it to base 64 and then dump it inside an image source attribute. And then that was my image. I didn't actually have to host an entirely separate image just for that. So that was one use case where it made sense to do so. But when you think about should you put images in your database, you also got to keep in mind that that's also going to grow the size of your database. And then you got to cope with that additional space. If you're just dumping 10 megabyte image after 10 megabyte image in your MySQL database, your database is going to get enormous very fast. So those are some considerations for that. But can you do it? Absolutely. Do people do it all the time? Absolutely. This question was from a Russian hacker. How do you design a database when you don't really know everything you might need? Sometimes when I create something, I end up in a situation where I'm sort of stuck because I'm missing a column in a table that I should have added from the get-go, or I've put a column in a table where I shouldn't have associated to that table. Do you just sort of wing it or migrate the schema and deal with the headaches associated with it? So the short answer is that first, you aren't the only one this happens to. This is very common. It's common to make a database and deploy that database and then find out pretty quickly that it's not actually really what you need. So typically when I start a new project, one part of that project is the data modeling part. And I actually sit down, I design all my tables, and I say, okay, based on what I know about my project and what I'm doing, I need the following tables, and each of those tables require the following data types. And I sit down and I create this up front. Sometimes I even go as far as actually linking the relationships together. And you can do that. There's tools where you can model that. I mostly just write the create statements, and then I just sort of like visualize how they relate to one another. I don't usually use a visual tool, but some people may find that as a benefit. And once you've sat down and you start thinking about it, then you usually flush out most of these problems pretty fast. And you end up with a database that's probably not perfect. No database is ever perfect because you never know exactly what you need. Sometimes you find out new stuff you need after you already make it. But really just you got to make the best attempt to get it right, get it mostly right the first time. And that's just spending the time to think about what it's going to look like. And after that, you're good to go. And you're never going to get it perfect. Over the course of the application, you're always going to add new fields, remove fields you didn't need, and that's just to adapt to new business requirements for your application. And that's perfectly common, happens to everybody. It's not a big deal. All right, let me catch up on some of the chat questions here. Best practice for keeping multiple MySQL databases in sync. So I'm going to answer that because that's slightly different from keeping a local and remote database. What you can do is you can use replication. That's one way to keep it in sync. So if you want a separate database to act as like a slave database, then you can set up replication to where every time there's a write on one database, then it gets replicated over to another one. And you can do that if you're trying to keep a backup or if you want like a read replica. So that's probably the easiest way to do it. But that's the, oh, okay, you mentioned MySQL specifically. So that's going to be the way to do it if you wanted a read replica or a backup. Okay, so Bargains asked, you said you don't have to define a schema up front with MongoDB. However, with Mongoose library, you must define a schema in order to work with MongoDB. Am I missing something here? I think what you're missing is that MongoDB is not designed necessarily specifically for Python, or I'm sorry, Mongoose is a Node.js thing, I think. So like MongoDB is not designed specifically for JavaScript, so you got to think of it as a data store that serves a larger number of purposes. The reason that they want you to define a schema up front in Mongoose is because Mongoose is from a class of tools called an ORM, which is Object Relational Mapper, which lets you map basically a JavaScript object to some data in a database. So that actually makes perfect sense to me that they'd want you to do that, because if it was just chaotic, then the ORM wouldn't really know what's in the database. So they want you to define it up front, because then that lets the ORM work well with MongoDB. Yeah, Node.js. Yeah, I made a mistake there. I don't know why. I knew it was Node.js. I don't know why I thought for a second it was Python. So yeah, it's just because MongoDB is a more generic platform and Mongoose is a very specific ORM that connects to MongoDB. That's all. But it's only necessary to define the schema within Mongoose. Otherwise, it has no way to know what's in the database. Answer my question. Thank you. You're welcome. Welcome to the stream. What would you quantify as huge amounts of data? I would say when your database is in the at least terabytes of data. I would say a huge amount of data is probably, for the purpose of what I'm describing in the stream, a huge amount of data is probably greater than 1 terabyte. I would say below that, I mean, MySQL can still work with billions and billions of records. It's when you get beyond that. And here again, I guess if a row is long, then you're going to reach that 1 terabyte quicker. But it's not necessarily about it's about two things. It's about the size of the row, but it's also about the number of rows you have. And it's also about how complex the data is, how it relates to one another, and how you intend to, work with each one. Of course, running queries on billions of data when you want to, join tables together and do complex operations on it. Yeah, MySQL is going to choke. You're going to end up getting like a 10-minute query. That's just what it is. All right, next question from GhostRunner0808. Postgres versus Maria MySQL for Nextcloud usage. If no thoughts on Nextcloud, just for everyday application use. Again, my personal preference is MySQL, but that's just because I've been using it for about 20 years now, and it's just what I know. But I have no problem with the other platforms as well. Calix asks, what is the difference between SQL and MySQL? So a lot of people ask this. This is a fantastic question. The SQL is structured query language. So SQL could be thought of as the language used to interact with database platforms that accept SQL queries. So this is true of MySQL, it's true of Postgres QL, and this is true of SQL Server. They all support generic SQL, and you can use queries into each of them. and that's that. So SQL can be thought of as the language, and MySQL can be thought of as the database platform itself. That would be the difference between the two. Another good question. This is one that everybody always asks about. How does SQL injection work? And then I'm going to assume also there's also a question later about how to prevent it, so we'll get to that as well. So when we're talking about SQL injection, we're talking about having one query, and in that query, so I made a query here. Select all from users where name equals, and I have this token here, $ curly brace name curly brace, and we're going to treat that as a variable. We're going to say that somebody is supplying the username, some user, not the developer. Some user is supplying that name, and then we're going to see what happens if we put a specially crafted name into it. So imagine I submit the name quote semicolon drop table users semicolon dash dash. Imagine if I take that name and drop it in place of this variable. The resulting query I get is select all from users where name equals blank string, drop table users, and then dash dash is a comment. So what I've done here is I've fed it a specially crafted username, and instead of querying for that user, I actually just deleted their entire table. Done through SQL injection. So this is the basis of how this works. Of course, it seems very dangerous, but it's very easily avoidable. And we'll talk about the avoidance part later because it was a separate question. But that's how SQL injection works. It's supplying input that alters the underlying query to behave in a way that was absolutely not intended. Yeah, pro gamer move. Little Bobby tables, indeed. So I got a question about HDF5, and I looked it up a little bit. I don't really have any domain expertise with that. From my understanding is that's a format for very large amounts of data. But beyond that, I unfortunately don't have a ton of knowledge on that. I apologize for that. Yep, parameterize your queries, sanitize your inputs, that sort of thing. We'll get to that shortly. All right, we're 75% done and about 75% done with the questions. Let me catch up on chat questions here. Ajith asked, how can I store data where data input rate is very high and also needs to render the data on the client side in real time? So when I think about a problem like that, I immediately think that the writing to the database can actually lag behind the sending of the data in real time. So like if we're writing a chat application, if I'm writing a chat application and we're sending chat messages, we'll say that there's tens of thousands of chat messages occurring all at one time. When a chat message makes it to the server doesn't necessarily have to store that message before it can push it down to the rest of the people listening, because it's just a chat message and it could be sent in two steps. They could push down the message, and then once it has, serial number data about it, whether it's a specific hash of information or something like that, then you could send that down in a separate step. So if the database was getting in the way of sending the data rate, you could either just lag the writing part to the database behind, but the other thing you could do is you could think about whether or not it even needs to be in a database, or whether you can write it somewhere else to where it gets written to a database later. There's a couple ways to deal with it, but I would say push it down to the user first and then worry about the synchronization of it later. That would be the best way to ensure that it gets down there. Will there be any mention of Apache Cassandra in the stream? So I guess I'm going to mention it right now. So Apache Cassandra is kind of in this class of databases that focus on storing large amounts of data at the cost of being a little bit less flexible. When you're designing Cassandra tables, you have to design them in a way where you're sort of like, when you're designing Apache Cassandra stuff, you're starting with the query and then you're making the table that supports that query. And that's usually because you're working with tons and tons of data. You don't need flexibility, you just need really, really high performance queries for one particular thing. Fidget, Felix Food, thanks for everything. $5, I appreciate that. Felix seems to get food from you every time I stream, so Chase, thanks to you as well. Thanks a lot for the 2. Your channel is cool. I appreciate that. Welcome to the stream. I haven't seen you here before, so hopefully I see you back, and hopefully you've benefited from the stream. So yeah, Apache Cassandra, because when you create tables in Apache Cassandra, they are being stored physically in the same way that you've created them. And that's how they look up things really fast, is in the way they partition the data. So when you come up with a query, like maybe accessing time series data by a date range, then you can structure your table in Cassandra to meet that particular use case in a very high performance fashion. And once you structure it properly, you could put tens of billions of rows in there, 100 billion rows in there, and it's perfectly fine because the data is physically laid out in the way that you intend to query it. And that's how Cassandra achieves such huge amounts of performance at the cost of flexibility. Here again, you can't just create some crazy table in Cassandra and then run all kinds of crazy queries on it like you could in MySQL. That's just simply not how it works. But like everything else, Apache Cassandra has its use cases, and it has things that's very strong at, has things that's very weak at. Let's see, my MongoDB. James asked, my MongoDB is hosted on Atlas and my password is stored in a file on the server directory. Is that bad? So a lot of people often ask, one common question I've seen throughout my career is, how do you store secrets? How do you store encryption keys? How do you store passwords? How do you store connection strings? How do you store all this kind of sensitive data? And the answer is, it's difficult. And it's difficult because if your application needs to connect to a database, then it's implied that that application needs that password. So it's sort of a cat and mouse thing. How do you protect the password when you have to have the password on the machine for the applications to connect to? So is it bad? No. Everybody does it. Most people have some sort of secrets file in their production server that contains a number of different information. And that's because the application needs those secrets. That's just what it is. But there's a couple things you can do, to make it a little more secure. The first of which is you can protect the box, protect the machine. Make sure nobody can get access to the machine. That's the first step. The second thing is make the application run as a user separate from the other machine. Separate from the other users, and make sure that your secrets file is only accessible by that user. At least in that way, if somebody were to access the machine as a not root user, but also not as the user that's part of the application, then at least that user cannot access the secrets file. But is it bad? No, happens all the time. You just gotta be careful with it. All right, a couple questions from AMP. Are all databases comparable with all frameworks currently present, or specific databases work with only certain frameworks, or are they not cross-compatible? So for most database platforms, client libraries will exist for every major and in some cases minor language. It's for MySQL, for instance, you'd be hard pressed to find a language that did not have a MySQL client library. So for the most part, you're good to go there. As far as ORMs go, an ORM, again, we talked a little bit about it, object relational mapper, and besides being a tool that lets you execute queries on a database without actually writing queries, it does something else that a lot of people seem to forget. And an ORM often allows you to write code that represents queries, and then it doesn't matter what your underlying platform is. Like I use SQLize for all of my projects. And what SQLize does is it can connect to SQLite, Postgres, MySQL, and SQL Server all through the same interface. So if I suddenly wanted to change from MySQL to Postgres, I wouldn't actually have to change any of my SQLize code. I could simply just change the data store, make sure all of the tables and columns are exactly the same, and then it should just work. And this is less true if you're writing raw queries, because then you got to modify those queries to match the other platform. Unless they're just simple queries, then by pure chance and coincidence, they might just work. Kevin asked, thoughts on when to use table locks or row locks? So the time that locks are necessary is when you need to do an atomic operation, meaning you need to do, say, 3 or 4 things to a database, and you need to ensure that those 3 or 4 things all happen before anything else happens. Then that's when it makes sense to use a row lock. And one use case, and one I actually just recently did, is I needed to guarantee that I would select a row, get the value from one of the columns, update that value, submit the update back into MySQL, and then commit that whole transaction. And I achieved that by selecting one row and locking it for update. And what that guarantees is that if some other process were to come in and select that row, either select all rows which contain that row, or select just the one row, then that client would block until my particular process finished. So by locking in update mode, it allowed me to do that atomic operation to that column and guarantee that when the next process comes in to request it, it's getting the updated data. So that's when you'd want to use it. It's typically for making sure that operations are atomic. Oh, that's a good question. Vinay asks, I get to hear regularly that NoSQL DBs like Mongo are horizontally scalable, whereas traditional RDBMS like MySQL, PGSQL, MySQL are vertically scalable. So when we think about vertically scaling, what we're talking about is increasing the capacity of a single server. So if I wanted to vertically scale a server up, I would take it from 1 core to 8 cores, and I'd take it from 4 gig of RAM to 32 gig of RAM. That would be vertically scaling it. When we think about horizontally scaling it, we think about cloning the servers. So if I horizontally scale my database, I'm taking it from 1 server to 10 servers. So all database platforms are both vertically scalable and horizontally scalable. Well, everything is vertically scalable because all you're really doing is just adding more capacity for resources. Horizontally scaling makes it a little more challenging because if you have 2 databases that span across 2 servers, then you now have a database in what's called a cluster. And most databases support this sort of mode with special configuration, but not all of them do. SQLite does not, of course, because it's just a single file. So probably what you've heard is that NoSQL databases horizontally scale easier. And that's absolutely accurate, and that's because databases like MongoDB are typically scaled horizontally by way of sharding, which is to say that half the data is over here and half the data is over there. And that's just because MongoDB is often used to store insane amounts of data that simply exceed the capacity of one hard drive. It's not uncommon for that to happen. So once that happens, there has to be a way of saying, all right, well, I don't necessarily want a copy of my data. I want half of it over here, and I want half of it over there. And that's the process of called sharding, and that is something that MongoDB is quite good at. So hopefully that answered your question. Okay, so that's it for the chat questions. We got a couple more, and we'll finish this out. We're probably going to go about 5 to 10 minutes late. Hopefully that's okay with everybody. Next one, is it advisable to change database management systems completely from SQL-based to NoSQL-based DBMS on an ongoing running project live on the internet? So what I don't know about this question is how large the project is. Probably what I'd say is depending on the amount of data stored, this could range from a simple task all the way up to a massive project. The more data you have to migrate, the more painful that's going to be. If it's in the latter case, I would definitely review the reasons that you want to switch, and then I'd make sure it's actually worth the effort and potential downtime, because this sort of thing is there's going to be downtime. I can't imagine migrating, tens of millions of records without incurring at least a little downtime. So I'd make very sure that that's a worthwhile thing. So we're back to SQL injection. How to protect your database from SQL injection. So the most effective way is just to sanitize the user input. And this usually involves removing characters that are designed to break the query, as well as escaping characters, or, well, it's really just escaping characters. Like if you quote a particular field, say with double quotes, then as long as you escape the double quotes, then you're fine. Because then it's not going to read it as a separate query or a separate string. It's just going to read it as a double quote that's within double quotes anyways. Oh, what are you storing in that DB that would allow that to be trivial? It would just be not a lot of data. Of course, if you don't have a ton of data and you can export it in just a couple minutes, then it's not really a big deal. It's mostly when you have tons of data and and the export takes potentially hours. That's when it's a problem. Another option to prevent SQL injection is just to use NoRM, because ORMs are going to handle SQL injection entirely for you, assuming that they don't have bugs. They will handle it entirely for you, and you don't have to worry about it at all ever again. So that's another way to handle it. All right, we got 2 more questions. Replication, how to read replicas and write servers interact with logs and transaction tracking to undertake replications, especially when it comes to guaranteeing atomic transactions. Great show, thanks for the help. So this is going to largely depend on what platform that you're operating in cluster mode and the algorithms that it uses to make that work. So for most cases, there's kind of 2 replication strategies. The first is master-slave replication, which is where writes go exclusively to the master server. You have one server that's for writes, and that's it. The other servers, the slave servers, are only for reading, and those don't take any of the writes. So what this guarantees is that you don't have writes coming into 2 servers, and then the synchronization where it needs to push those writes out to the other nodes. And this makes it a lot easier. The drawback with master-slave replication is that if you have an application that's going to be high write throughput, then that's not going to work very well, because your master server is going to be at extreme load, and the slave server is just going to be idle because not a whole lot of read requests are coming in. So, but as far as how the replication occurs, once a write occurs, the master node writes it to a sort of bin log, and then it pushes it out to the slave servers, and then they bring their database up to speed. The other kind of replication is multi-master, and this is where you have a bunch of databases in a cluster, and they're all considered master databases. They can take writes, they can take reads, and then they handle synchronization issues as part of the clustering software that's built into that database. How it goes about that is complex and specific to the platform. I'm not even so sure that I 100% understand it, but for the most part, they are, there's some mechanism in there where they can talk to one another, and they can make sure that they've synchronized properly. But even like Galera cluster, from MariaDB, they even state up front that if there's high latency and there's high write throughput, then the possibility of consistency issues, goes way up. So, but the benefit you get with multi-master replication is that you get a better, you get better availability, because they're all read nodes, they're all write nodes. And then as far as the actual transactional, the transactional piece for replications, they're already transactional. So like if you made an atomic operation, if you made an atomic write to a database, then it's going to be applied to the replicas also as an atomic operation. So it's not like it's going to break your atomic operation in half, apply a part of it, and leave you in an inconsistent state. So if it went in transactional, then it's going to be applied to the replica transactional. This question is from Vengeance. Thanks for taking the time to do this. I got a few questions for Hibernate, Derby, Java, EE, HTML related stuff. So I've integrated a database on my web application, and I want to integrate a second one. How would I do that in the correct way so I can link them with a primary key or a foreign key function? So you can absolutely use multiple databases and multiple tables in the same way that you would just use multiple tables within a single database. We often call this a cross-database operation, or cross-database joins in the case of joining two tables together. It is seen as a little bit less performant than tables being joined within the same database, but it's absolutely possible, and it's a common thing to do. And then as far as foreign key, primary key, you can absolutely, at least with MySQL, you can absolutely reference a table from another database as a foreign key in a table from another database. So that works perfectly fine. The second question was, is it possible to add columns into an existing database via user input? And sure, absolutely. I mean, if your client allows you to make queries against your database, which that's true of every single one, then there's no reason at all why that query couldn't add additional columns. However, I would question why you wanted to do that. That would seem sort of weird because you'd be breaking your schema. I've never heard of that, but I'm sure there's a use case out there for it, and if you want to do it, you absolutely can. And then the final question was from Shirag, how to create a database. So it seems like a simple question, but it's, first you gotta download your platform of choice, whether that's MySQL or Postgres, SQL Server, Mongo, whatever you want. Start by downloading it, get it installed, get it running. Next, design your tables. In the case of a schema style database or relational database, even if you're using MongoDB, you don't necessarily have to design your schema to put in the database and lock it in, but you still got to kind of, even with MongoDB, Elasticsearch, and all these other NoSQL schemaless stuff, you still have to think about how the data is going to look. Just because you have the flexibility to add any data you want into, say, MongoDB, you still got to have it in your mind what sort of stuff you anticipate storing, because if you're just storing random stuff, then how do you write an application that just deals with random things? Yeah, having a basic schema helps for MongoDB. Absolutely. You got to at least, even if you're not forced to actually lock it in to that schema, it's good to at least have it written down. I always do it. It's one of the very first steps before I take on any projects. I do the data modeling phase. I make sure everything's good. And there was one late question that came in. I didn't answer it up front. I just noticed it this morning before we started the thing, so I'll just answer it live. So SQL Server development, applications, connections to database, understanding CPU, storage, memory, interaction requirements. The only thing I think I'll mention there is that if you're running your database in the same place as your application, then you got to be cognizant of the fact that resources are going to be limited. This is doubly true if you're running it on a server that has one single core. If you're running your application and database on the same server, it would make sense to have at least 2 cores. That way you can think of as the database has access to one core and your application has access to another. Of course, you can't really, you wouldn't lock them into using one core or the other, but you can guarantee with relative certainty that your application will be able to serve requests in parallel at the same time as your database is functioning. So you got to kind of look at what's best. As far as storage goes, make sure you have enough space to store all of your data, both present and as your data grows and your application grows. As far as memory, you got to look at what, there's obviously caching that occurs in a lot of databases, and caching, of course, is going to come from memory. So having high amounts of memory available will allow for more caching, which will allow for higher performance queries that can just get the information from a cache rather than having to requery everything. Question, is there a risk that the DB connection will be broken if both app and DB are running on the same machine? Not really, and even if that were the case, even if that somehow happened, then the client library should reconnect anyways. So that would be uncommon, but it's also not really a big deal. That's funny. Is SQL compiler interpreted? You all know the answer to that. No, it's interpreted. It's just you write the query, the engine reads it, and it gives you the result. All right, just reviewing last minute questions, and I think we're going to finish up here. Oh, I want to answer this one. Donovan asked, what's the benefit of using indexes in MySQL? So this is actually true of also Postgres and SQL Server. So the best way I can describe an index is you can think of it like a bookmark in a book. If you're running a query without an index, imagine you have a 500-page book and you run a query that says count the number of times that the word dog appears in a book. So if you don't have an index, the only way you can find out is you have to read every single page, and you have to just annotate every time the word dog appears. And then once you get to the end of the book, you can say dog appeared 92 times. Now, with indexes, just imagine that you have a bookmark on every page that contains the word dog. So now it makes it a lot easier to count. You simply just go to each bookmark, you count the number of dogs on those pages, and then you say, I found it 92 times. So that's why you want to use indexes, is it drastically speeds up your queries, especially once you get over a certain amount of data. Without indexes, the database has to do what's called a full table scan, and that's kind of what I described, where it reads the entire book to find all instances of the word dog. And a full table scan, it may seem fast if you only have a few thousand records, and that's because MySQL can read through 3,000 records basically instantly. But once you've got millions and millions of records, you must index on fields that you're going to query on often. Okay, somebody please block this guy. Hide user. There we go. Thank you. Select all from EM knowledge, order by year. Thanks for sharing the knowledge once again. You're welcome. And thanks a lot for the 140 South African. I think that's just about, okay, we'll get rid of that. I'm just checking chat just to make sure I haven't missed any questions. I want to make sure that I answered all the ones here. Oh, somebody asked about views. So what views are for a database is, views are kind of this thing that people don't use that often. Views could be thought of as a virtual table that is rendered by way of another underlying query. So the reason it's called a view is because it's a view into your data without actually being real data. So I sometimes use views, not all the time. I use them usually when I can do them efficiently and when I have an application that needs to access a database directly. Like in the past, I've worked with software that needed to access a MySQL table directly. It had no interface layer. So because that application needed to request data that spanned across several tables, I needed to basically create a view that contained the combination of 3 tables. And by doing that, I was able to feed that view into that application, and it was able to read the data it needed without any special stuff. So that's when views are really useful. But views can get out of control. They can get, they can get complex and they can get slow, because every time you can create a view that selects from a view, and then over time, it makes, I don't know. It can get out of control if it's not used properly, but if it's used right, then it's a very good tool. Can use it to hide data in columns. You can use it, yeah, absolutely. You could create a view for a table where you just exclude certain columns. You can absolutely do that. That'd be another good use case. If you needed an application that only access specific data, then that would be a very good use case for that. All right, don't need that. Oh, okay. I gotta ask this question. So, what's the point of having a SQL standard when each database has their own platform-specific features? So, like SQL itself, for the most part, all relational databases that use SQL as the language to make queries into their database support 100% of what I consider like core SQL features. There are additional features that certain database platforms will offer, but it's not that big of a deal because the stuff they're offering is more quality of life stuff, but all the core SQL stuff already works. Like you could take basic queries and run them across all relational databases, and they're pretty much guaranteed to work. It's usually like MySQL is SQL plus MySQL stuff. You know, Postgres is SQL plus Postgres SQL stuff. So the only stuff that wouldn't port is stuff that wouldn't actually work anyways. So like Postgres has some specific, geo-related functions, and obviously if you ported that over to MySQL, it wouldn't work just because MySQL doesn't have those geo-related functions. So it's not really that they're breaking the standard, it's that they want to go beyond what SQL is and try to set their database apart. But as far as core SQL, you can pretty much guarantee that's going to work everywhere. Yeah, limit. Another one is top. Like SQL Server uses top. You can say like, give me the top 10 records, and that's only applicable with SQL Server. But here again, it's not. That's only specific to that. One would just use order by and limit. I think that's pretty much it. There were a bunch of questions that I didn't answer, but I think they got answered with other questions. So I think we're gonna end it here. I think this was a very productive stream. So we'll end it here. So I hope everybody had a fantastic time on the stream. I hope everybody learned a bunch. We covered a ton of stuff, probably like 30 submitted questions plus another 20 from chat. So a lot of information. I know we went a little over, about 18 minutes over, but that's just what happens. We get a lot of information going and we just can't stop. So we also have a Discord server. Of course, I mention it every stream, and probably a lot of you who are here are already on it, but if you want to come join in on discussions on tons of different topics, both programming related, database related, engineering, math, and a bunch of other stuff, feel free to join us over there. The link is right there. You can come check it out. I'm also there all the time. If you want to come say hi to me or interact with me, that's perfectly fine. I am definitely on my own server. I don't avoid it like other people do. So definitely join us there. We got, I think, 11,000 people, of which about 3,000 to 4,000 are online. So a lot of stuff going on that server. We also have EMKC, which is Engineer Man Knowledge Center, where you can do coding challenges and then get rewarded with special roles. And then also anybody who donated today, if you've never donated before, please let myself or one of my team know that you donated and you get a special supporter role. So be sure to check that out. As far as the next stream, we'll be doing it in about 1 month. So probably, let's see, August 1, 2, 3, 4. It'll probably be August 29th or September 5th, probably the 29th. I don't know exactly what we're going to do it on. We got about 3 more streams for the season. Season 4, I have some different plans for streams in 2021. So I'm still fleshing those out. I'll make an announcement on that at some point. There's also a stream planning channel on Discord if you want to get kind of a sneak peek on what's coming as far as the streams goes, or if you have a suggestion for a stream you think I should cover, please feel free to put it in that channel. And of course, if you're new to the streams or new to the channel, I do put out a video every Sunday other than stream weekends. We're currently doing HTML and CSS, so be on the lookout for those videos in the coming weeks. And I think that's pretty much it. Thank you to everyone who came to the stream. We had a total of 217 people, I think, at max. So that's a fantastic stream. We put out a lot of data, and I hope everyone benefited on that. I hope to see you on the next video, the next stream, or on Discord. And until then, have a fantastic rest of your weekend, evening, night, and wherever you are. And I will see you around. Take care.